he's been maintaining for a while now. And so the foundation has taken notice and they are shining the light on it for other people to know about it and start using it. It's the same thing. The author of Coverlet was not done by Microsoft originally. The foundation took notice of it. They brought him on to do presentations, and Microsoft sort of adopted it. So now Coverlet is buried within the Microsoft ecosystems. So that's what the .NET Foundation does. They also advocate for open source developers. They evangelize on the benefits of using the platform, and they do other administrative support. They have a number of working groups. Some do marketing, and some also do outreach. The outreach is what we were particularly interested in some time ago, because outreach is concerned about education. How do we get enough people to start using .NET? And so the last time we met and discussed in the outreach working group, we talked about a number of things. We made plans of getting to bring more younger people into the .NET ecosystem. So younger people means that targeting people at the senior high level, doing sort of a road show and going around or across Ghana to do that, so that by the time, because we realize for languages like Python, before the people come out of senior high, they already have heard about Python and they know about Python, right? So right now, .NET Core is younger than Python, but we still treat it as though it's an old people's language, which is the prevailing notion out there. So some of the hope is that the outreach committee is going to be able to get newer people to adopt .NET and bring fresh eyes into the ecosystem. That's just about a summary. I'm going to drop a link in the chat to the site, and you guys can take a look and read some more about the foundation and some of the working groups that are available. I'm also going to share their GitHub for those who are interested to find out more. All right, thank you. Over to you, Clifford.
Yeah. So thank you so much for this is interesting. So thank you so much for telling us more about .NET Foundation. So before we proceed, as Y said, Monday I'll be at the .NET Live, which is a Microsoft .NET official YouTube platform where people normally come and talk about .NET. So I'll be live and talk about the package that we have built, which is officially built by this community, country.data.net standard, which is a package that can help you as a .NET developer to get a country data. So if I think 4 p.m. Yeah, so if you guys can join, then we all support the community. So thank you. I'll drop the link and everything for the package. You can go in there and make sure to give the package a star, and also trying to tell others about the package. And together we build a strong community here in Africa. So thank you. So we proceed to the next section where we are going to introduce our speaker. He's going to tell us about Akka.NET and Kafka. So this is interesting topic that every .NET developer wants to learn about. So yeah, so our speaker today is called Frederick Lutrot. He's a senior software engineer. Yeah, I don't want to just go ahead and introduce him, so he can introduce himself. So, sir, if you can hear me, you can introduce yourself and then tell us about, what Akka and Kafka can do. Thank you.
Yes, you guys can hear me, right? Am I audible?
Yep, you're audible.
Okay, yes. So my name is Frederick Lutrot, and a little bit about myself. I've been into backend engineering for over 10 years. I started my career at Fortis, moved to Texel Limited, and then I finally worked at Haptel Limited, where I was the head of core platform engineering for a couple of years before I switched countries. So currently I'm in the United States, and yeah, I'm working with some company I don't want to disclose for certain reasons. So yeah, I'll keep it that way. And so yes, today I'm really excited to be here to walk you guys through on Akka.NET, Kafka, what you can do with it, and how it can make your life pretty easy in terms of building real-time scalable distributed system. So welcome on board. Can I start, Clifford?
Yes, please, you can start. Yes.
Okay, so I'll share my screen and then we will see. I'll just give you some brief. Let me know once my screen. I'm going to. You guys can see my screen, right?
Yeah, you're visible.
Let me just then.
You have to flip your view. We are seeing your presenter view instead of the slideshow. So go to swap displays.
Okay. Where will swap display be? Okay, I see it.
Yes.
Okay. All right. So, like I mentioned, my name is Frederick Lutrot. And today we are going to look at building scalable distributed system with Akka.NET and Kafka. Trust me, you are not going to build that today. I'm going to guide you, give you the concepts that you need to know and familiarize yourself with in order to be able to do that. Today you are going to see at least a quick demo of what you can do with it. So just for your information. So just to go into the basics, if you have any question, you can probably interrupt me while I'm speaking, since some of the concepts may look pretty abstract. In general, what is distributed systems? I don't know if anybody has heard of the term distributed system, but basically, layman terms, we have several computers. You don't have a supercomputer, and so you are like, okay, let our powers combine, right? Then you turn into Captain Planet. So if you've in the olden days when we were kids, we used to watch Captain Planet. So we have everybody bringing their powers together to form Captain Planet. So with distributed system, we can bring so many computers together to get the power of a huge giant cluster to be able to do a certain work that one single computer can do, right? And so we get that benefit from being able to see a group of systems behaving as if they are one individual system. So basically, that is what, when we talk about distributed systems, we are trying to achieve with that system. And if you've heard of the term microservices, you want to build small services that are focused on one particular thing, and they do that, and you can scale that. So if you are good in doing one thing, we can replicate you so many times, right? In order to be able to meet the demand. So the concept of distributed system also help in the concept of microservices being able to come, so that you can have one microservice distributed across so many different computers, and they all end up doing the same thing to achieve a common goal. And what are some of the challenges that distributed systems address? I mean, the first one is scalability. Now, if you have one giant computer, I mean, in terms of resources, there's limitation. You can't outgrow to a certain number. There's a maximum RAM you can get, right? But with scalability using distributed system, you can always have n number of, let's say, a 4 GB desktop machine, and you put them together in a cluster, and they become a huge machine doing wonderful work, right? So scalability, that is where we get the scalability from. And reliability. In terms of reliability, once you have a distributed system, you can implement things like failover. Okay, if this guy goes down, this other guy will come up and become the leader and take over and and run the service or whatever process that needs to be run. So it pretty much gives you some strong reliability. Then same thing, fault tolerance. If there's any little issue with one server, you have the bandwidth to be able to tolerate, a service going down, because you can have another guy taking over the faulty computer, immediately switching over, right? And so you get that benefit. And then concurrency, you're able to process things concurrently, and you don't have to do something, get it done before you move on to the next. So these are some of the challenges distributed system addresses. So that is just a quick overview of that. So why Akka.NET and Kafka? To build a distributed system is pretty much going to be a headache, doing that all from scratch by yourself, right? So with the emergence of Akka.NET, they abstract a lot of all the low-level complexities from you. So you can just focus on, hitting your business logic and just going live, deploying live. That is the most important thing. And Kafka is also pretty much plays a very key, important role with Akka.NET, because you need to get some sort of input, right? And in order for you not to have messages piling up on you and you need to process them quickly, you need a system that can hold on onto that messages, and anytime you are ready to get the messages, you can just go onto that system to get access to your message and you process it. So Kafka gives you that ability to store messages, which are like events or actions that needs to be done, and without any pressure. Once you are ready, you go get your message, you process it, and you move on. So that is the benefit we get when we combine Akka.NET with Kafka. We're able to enjoy parallel processing, we get benefit of resiliency, and we're able to get high throughput messaging. So if you have 1 million requests coming, so far as your Kafka cluster has enough capacity to accommodate all that 1 million messages coming in, you are good to go. You can also build consumers in Kafka consumers that can also scale with the number of requests that is coming. So the combination of Akka.NET abstracts a lot of things in terms of distributed system building, distributed system concurrency, parallelism, everything from you. And Kafka gives you the ability to hold on to messages. When you're ready, you go get it and process it. Okay, so let's quickly delve into Akka.NET. Like a quick overview of Akka.NET is an actor-based framework for building concurrent applications in .NET. So we have Akka. Akka started in Scala, and I think it was ported by a company called Petabridge. And Petabridge has actually done a really good job porting the Scala version of Akka, and now, I mean, there are more features and they have a lot of training they do year on year that if you're really interested, you can, participate in some of those sessions and you get to know more about it. So this is an actor-based model that leverages threading, processing, and the basic computing languages to process tasks for you. So that is what Akka.NET is. So it's a framework. So a framework means a lot of the hard work has been done for you. You are not building it from C# from scratch, using semaphores and stuff. No, everything has been abstracted. So that is the beauty of Akka.NET. And what are some of the core concepts that they leverage in order to help you build concurrent and distributed applications? They have something we call an actor. So in movies, when we say an actor, somebody is, let's say, the protagonist. One person too is the antagonist. They have specific thing they do, right? So you can build so many actors. You can have the lead character, you can have the supporting character, you can have somebody who is this. So look at it like a movie. At the end of the day, something needs to happen, and everybody within the movie have something to offer or something to do. So that is the actors. Now, what are messages? Messages are more like every actor needs a sort of an input to elicit a response or an action on it, right? So you get that message to do something, then the actor responds by doing the action and either also telling another person that, hey, I'm done with my work. Who is next to do something, right? And so the message is a means of communication that actors uses to exchange um, messages or events for them to take actions. Then we have concepts like supervision. Supervision basically means, most of these terms are pretty layman English. So supervision means when somebody delegates a work for you, they have to supervise you and make sure that you are doing the work, so that when you are done with the work, you can report back to them, right? So in an actor or in an Akka.NET actor system, you can have an actor spin up a child actor, and then that actor can be a supervisor and tell the child actor that, hey, do this work for me. When you are done, inform me so I know what to do, right? So that is the concept of supervision, and we have different strategies around supervision. And the last concept is routers. So routers basically mean you can have a group of actors that are working on the similar tasks for speed and performance in general. So it can be like, okay, we have 20. What example can I use? You have 20 students and you have one teacher, and the teacher is marking their script or assignment. It's going to take more time for the teacher to finish the script for all these 20 students. So if you want it faster, you can introduce another teacher. Then you have two, right? Then it becomes faster. If you add another one, then it even becomes even better. So that is the concept of routers, having a group of actors working on the same messages for speed, right? What other things in key features for distributed system are, like I mentioned earlier, fault tolerance and location transparency too. So you're able to know wherever your actors are on any server at any time, and you can remotely talk to each other. Okay, so now that we know about Akka.NET, let's talk a little bit about Kafka. Then now we can marry the two together. So Kafka is a distributed event streaming platform, and by distribution, it basically means that actors or processes or some sort of input service can drop in some data into Kafka that, hey, I have this list of events that is of interest to a certain application, and I'm going to stream it into your system so that you can broadcast it to the underlying system that wants it, right? So it's just an event streaming platform that we use, similar to, if you know RabbitMQ, it's the same thing. If you know Amazon SNS, similar to notification service, it uses the same concept. So Kafka is pretty robust when it comes to message queuing, and so most companies actually prefer to use Kafka for huge system. But if it's a lightweight system, you can go for some of the other available ones on the market, like RabbitMQ and stuff. Okay, so what are some core concepts you need to understand when it comes to Kafka? You need to understand producers. What is a producer? A producer is basically a service that generates the event that needs to be consumed, right? So a producer produces, from just the word, it produces data into Kafka. What is a consumer? A consumer consumes data from Kafka. So a typical data could be, let's say, you have an order system. So there's an API that receives a request that, okay, somebody wants to order fufu and goat meat soup. We get that event, we produce into Kafka, and you have an order processor system that will be like, okay, there's an event that came, somebody wants fufu. Okay, what should I do? Okay, I need to go to the chef to start getting it ready, and a whole sequence of events follows, right? So that is a producer, and we have a consumer who consumes that data that has been produced. Then the next thing is topic. Because there are so many events that can happen, infinite number of events, you need to have a way to signal whoever is interested in that data that you need to ship to, right? So you need to give it a topic name. So for example, if it's, let's say, a food event, you can say that, okay, my topic is order.food. 123. It means that somebody has ordered the order menu 123, and so somebody listening to that topic will get that payload and will be able to act on it, right? And the last concept there is partition. So Kafka, I mentioned, is distributed. It uses several clusters of machines to become a huge, let's say, server that can handle all this millions or billions of requests that is coming in, right? So we have something called partitions. So you have one, when you produce a data, it could go to partition 0, which can then be replicated to some of the other partitions just for uh, resiliency, right? And so that is the last concept that I wanted to talk about. And in general, the benefits: scalability, durability, and low latency data streaming. Okay, so now that we know the two, if you do Akka.NET plus Kafka, you become like a Superman. You can do so many things. And the reason why you need to combine these two is you are able to build event-driven architecture for reactive asynchronous processing pretty easy. It's like a no-brainer. Don't need to be a top shatter to be able to do this. The steps are pretty simple, right? And another thing is decoupling. You can decouple your components and you get the benefits of high fault tolerance, because you can just spin up actors to do just simple things. You don't need to you can actually achieve something like the single responsibility principle easily using this Akka.NET, a very good Akka.NET architecture, right? And you're able to scale for real time. You can spin actors on the fly. You can, when I say spin actors on the fly, you can just, as and when you are getting more requests, you can create child actors to handle those requests. You don't need to just have like just some one actor queuing the messages before they process it in a serial manner. You can actually spin an actor to go handle the request. When it's done, you can just scale it and it goes out of your memory. Okay, so what are some of the use cases? You can use this in payment processing, because you can imagine you have billions of people coming to your store to buy things. You want to be able to process their requests pretty fast. Order tracking too, same way. Real-time analytics. You want to analyze information coming in, maybe Google Analytics for your website, real time data keeps coming, and they use some of these things to, analyze the data and give you real time information for you to be able to make very quick decisions, right? So, how do we implement Kafka in Akka.NET? I mean, popular among them, there are libraries you can use. One of the common library when it comes to .NET is the Confluent.Kafka, which is pretty uh, stable. It has stood the test of time, and most people who implement Kafka in .NET uses that library. And you need to be able to produce events. So I'm going to do a demo on how to produce an event using into Kafka using .NET or Akka.NET. And also consuming events, right? So you need to be able to consume, like I mentioned. You connect to the Kafka system, you produce an event into it, and you consume an event into it. So we do a demo of both sides, being able to produce and also being able to consume into it. And in building a consumer, there are so many options, like so many ways you can build a consumer. You can use a console app, you can use a worker service, you can use something we call Akka Stream Kafka to build some, back pressure consumer, back pressure enabled consumer you can do so many things with it, and you have so many options over there. All right, so the Akka system, if you want to build an Akka system, what are some of the Akka hierarchy and design? We have a parent, you can have a child actor. So when you start a system, you need to have some sort of a parent, somebody who comes as like the root, right? That every other thing can come from. So the actor system look at the actor system as like the world, and look at the parent as like Adam, the first to be created. And now we all came from Adam, right? So something like that. That's a good analogy I can give. Then we have concept like supervision. You create a child actor, you might be interested to supervise it and give it instruction that, hey, if you meet this kind of exception, do this. If you meet this kind of exception, do that, right? So that is the supervision. And the failover strategies will be like, hey, if you meet this kind of exception, and restart yourself or kill yourself or do something, right? So there are so many strategies based on your use case you can implement to and deal with that. Now we have another concept in Akka called routers, and this routers helps you in scalability, right? So like I mentioned, you can, instead of creating just a single actor to handle a message, you can spin up like a router of 5 actors, and you can give it an algorithm that, hey, let's use the smallest mailbox algorithm or strategy, which simply means look at all the actors you've created, go inside their mailbox, the one that have less messages to process, you drop this new message for that guy to process. So this is one strategy. You can also do round robin, which means go around. So first request come, you give it to this guy. Next request come, give it to the next actor in that order, right? And we can have random algorithm or random strategy. That one means randomly select any actor and drop the message to. They all have their use cases that you need to understand before you choose a type of strategy. But most commonly, smallest mailbots will do the job for you. Okay, so in the demo, you see some basic actor structure and message handling. Okay, so I already explained routers to scaling with routers to you. And now advantages, challenges of using Akka. Advantages, flexibility, easy to spin up actors just like that to do things, pretty easy. You get the advantage in real-time processing, and also distributed fault tolerance is another advantage you get. What are some of the challenges? Message ordering, because this is really concurrent. You check your logs and you be like, okay, this guy got the message. This actor got a message before this, and he did something that. So you struggle in terms of order, right? You need to get order. You need to implement it in a certain way. But by default, if you don't follow a certain architecture in building it, you might have ordering issues and idempotency. You need to be able to keep getting the same result over and over again for the same thing you do. And with actor systems, sometimes you can struggle with idempotency because of its concurrent nature we have. And also, the final item I want to talk about is the complexity of the actor supervision. Like, you can go with a bare minimum. Okay, when you hit an issue and an actor hit an issue, okay, just restart it and move on, right? And there are other times you need to also be able to say that, okay, depending on the actor that got an issue, if an actor is, let's say, a database actor gets an issue, an exception in trying to connect to the DB, you need to know that the same strategy you use for the same supervision strategy you are using for that guy might not be the same as an actor that is just maybe doing a certain work that is like very trivial. If he doesn't do it, like he can move on, right? So there's a bit of complexity. You need to understand the system you are building and be able to know which supervision strategy to use. So with all this talk, we can jump into some demo. If you have questions now before I jump into the demo, you can ask. If not, I can just do a walkthrough and show you some of the beautiful things you can do. Okay, I guess since there's no question here, I'll just go. So over here, I have a .NET 8 project that I created. Let me just. Okay, so just two projects. Let's say we have a lottery system that generates numbers, right? And when those numbers are generated, we are going to produce. That's why I call this lottery the generate numbers the producer, right? So this guy is going to just show you how to get events or messages into Kafka, right, in .NET. A very simple program, and there are so many ways of doing this. You can so many ways, like I mentioned, and I did this way because I just wanted to also talk about some other advanced concept called Akka stream, but I'll pause on Akka stream for today's episode. But basically, we have a source, we have a sink. A source is basically most of the words are literal English meaning. Source is where you get your data from, right? Sink is where you are pushing your data to. So basically, that is what source and sink means. So we have a source. We say let's generate a range of numbers between 1 to 100, and then let's produce all this as events into Kafka. So we have a producer here from the producer builder class that we can call a produce on, passing the topic. So now there's a topic, test topic, which means you are saying that, hey, I'm going to push a series of events on this topic. If you are really interested in test topic, you can consume it and you get those events and you can do whatever you want to do with it. So this is how we produce events into Kafka. So if we, for example, run this, boom, right? We have 100 messages produced because that's what we just said here. Now, all these messages, if you've not seen Kafka before, I have a local Dockerized version of Kafka here that I can show you. This is like the Kafka tool. So within the Kafka, you have your consumer groups, which means consumer group basically means for the same message in Kafka, different groups of people can access the message, and they are offset, which means their last event that they picked up will be marked so that the next time there's a new event, you not reconsume the messages. Because if that is not done, you can imagine if the events that you are consuming has to do with, let's say, payment, and you need to send people money. you reconsume the messages, you are giving free money out and you'll be causing financial loss, right? So that is the concept of the groups here. You can have different groups consuming from the same topic. If you want to reconsume old messages, then you just change the group ID and you'll be able to do that. And we also have the topic here. So far, I just have this test topic I created here. You can see the partition. We have just messages going into partition 0, and we have about 200 messages in, because I already had produced 100 messages there, right? So we should be able to now consume these messages. So back to a consumer. Now you've seen how we produce message. I have this project I call notification.consumer. I'm going to use this notification.consumer to now explain the Akka.NET actors, routers in a bit detail, right? The first one was just producing. It's not doing anything Akka.NET. Consuming is where the whole beautiful thing comes in, because you consume the data, you need to process the data, and you want to process it in a fast way, right? So let's look at a use case like this. You want to send an SMS to all your, you want to do an SMS blast, and you have a lot of numbers. Let's say we have 200 numbers that we have pushed, and let's assume all these are SMS numbers. Now you consume it. So to build a consumer base, this I use a worker service approach to just build this, right? So we have this worker we call Kafka consumer, and with this Kafka consumer worker, all that you are doing is you have your execute async override method here. You create your Kafka config. All this means is, oh, group ID. This is the name of my group ID. Bootstrapper service, the name of your Kafka cluster. So this could be multiple. If you have a cluster, you could have other URLs in there. Then it forms a cluster. And auto offset resets basically means that, do you want to consume earliest messages, or you want to consume latest? So we have two options. Latest means that only consume messages that are produced right now. Any old messages, don't consume. Earliest means that if you're a new consumer group, you can go back in time and consume any messages that was there before you. That is the difference, right? Then we go ahead and we subscribe to the topic. So this guy generate numbers produced to a topic called test-topic. This consumer we are creating is interested in this topic, so we are going to subscribe, which means that you are telling the consumer that, look through this Kafka cluster. I am interested in any event that has this topic, right? So you subscribe to that, and once you subscribe to that, you begin consuming messages as and when it is produced into the Kafka cluster, right? And when you consume that message, you can get the raw value of the message, which is like a string, and you can either deserialize it into an object if that string has been serialized into a string. You can get it back into whichever object you have, and you can use it for whatever you do. In this case, it's just a simple string. So all I did was like, okay, instead of processing this message here immediately, which can be a problem because this guy really consumes the messages pretty fast. So if I'm doing a heavy operation, an operation that is taking a lot of time, then I'm going to introduce some lagging into my system, right? So I want to be able to leverage Akka.NET to be able to what? Build a system that is very fault tolerant, that is scalable, that can work on the fly. So in order to do that, I'll go into how we set up this whole Akka system from the program.cs. So in order to set up an Akka system, let me just come here. an actor system needs a name, right? So you can give it any name you want. In my case, I call this the lottery actor system. Now you need to create your actors. So like I mentioned, actors are just classes, like abstract human beings or abstract robots that you allocate some tasks to do. Some can do the actual task. Some can just be like a traffic warden and be like, okay, I know where everybody is, so I can look at the nature of the event that I've received and I'll direct it to the right person to do. So it's an infinite number of things you can just do. In this example, we have two main actors. The first one is the main actor, which is like our Adam in our analogy, right? That is the first person you want to create in the actor system so that you can use it to orchestrate any other actors. And now you have somebody we call an SMS actor, which is like a child actor, right? In this case. So you create your main actor here. As you can see over here, I didn't create an SMS actor. This is I just registered it. I didn't create an SMS actor. I only created the main actor because I'm like, okay, this is just going to be like the parent actor within the actor system when it starts, right? So I create it using the actor system, and once I am done with that, I give it some, default supervision strategy. Like I mentioned, one of the concepts we learned was supervision. So what are some of the type of supervision strategies we have? In this case, I'm like, hey, anytime you hit an exception, an actor initialization exception, stop it. Stop the actor completely, right? Because you are not able to what? Do anything if you can't initialize the actor. But if it's any other exception, you can resume the actor back and let it keep going. That is what all this guy is doing. So I create this strategy, which is a one-for-one strategy, which means this strategy applies to just that instance of the actor that you have. It doesn't apply to the children of that actor, right? And there are different strategies that you can check out here. All right. So going back to the program, the CS, we create this main actor, we give you this supervision strategy, and we are like, okay, you can now have the name of a main actor, which could be anything. You can just name it anything. It's just a string, literal here that I'm saying that, okay, in my own, I'm just calling it the same name as the class name, right? And then once you have that, you run the system, we get this actor created in memory for you, waiting to process requests. Now, back to the Kafka consumer worker. Over here, anytime you consume a worker, instead of doing some work here, so let's say do some work and the work is heavy. Maybe it takes about maybe I don't know 5 minutes, whatever minutes, right? This guy is going to be processed in a serial form, right? So you need to finish doing the first message you consume before you get the next message, and it's going to introduce a very latent system. Your system is going to be very, latent, right? And so we have a main actor we've already created in memory waiting to get some requests. So we are like, okay, we are going to do a tell to this main actor because we know, like another thing, location transparency. So because we are storing the reference of this actor into this variable, the actor system is able to locate this actor in memory and give it this message you are creating. Over here, I could have created a class. I just wanted to just use tuples because they are immutable. All your messages needs to be mutable, right? In an actor system. So because tuples are inherently immutable already, I could just wrap the string around the tuple. So I just do tuple or crate, I pass the value of the message that is coming. In this case, it's just a simple text, right? That is coming. Now, once the message gets to the main actor here, handle message. So the main actor is here. And also you can use, we have a synchronous version of the actor. We have a non-synchronous version. So in this main actor, I just wanted to show you that you can just do the synchronous version, which is the receive, just the receive, and process any message here as such. So over here, all we are doing is to get a message in the main actor, and we are like, okay, I am the main actor. I'm like a traffic warden. I don't want to do any logic. I just want to look at the message and create a child actor and give it the work to go and do, right? So that is what we are doing here. So I'm using my context. So me, the main actor, I'm going to use my context to create this SMS actor, and I'm going to forward this message to it. And when I forward the message is going to go with some of my metadata, the metadata of the main. If you just do a tell, then the message just goes. So we have two options. You can do a tell or a forward. If you were in the last Akka.net meeting, you know the difference here, right? So I'm like, okay, let me just forward the message that I got to this new actor that I've created. That is going to be my child actor. So in terms of supervision, I am going to be responsible to supervise this actor. That is all that this is doing. Then this last line here is just saying that, okay, once you are done with your work as the actor, I want you to die. I don't want you to be in memory wasting resources, right? So because actors processes message in a serial form, they have their own mailbox inside, which can take millions of messages, right? This message goes into the mailbox in a first in, first out manner, and this one goes in following this. So it gets this message here, and once it gets the message, it processes its message. So in this case, a simple login. That is what work is doing, right? I'm like, okay, I received this message. I'm going to send SMS to this string which is coming in here. Then I am done, right? And you can see here, I decided to use the async version of the the async way of receiving messages, receiving incoming messages for the actor, right? Just to show you the difference, right? So we are able to then now go ahead, process the message, and if you want to report back to our parent actor, you can do a sender.tell, which means whoever sent me the message, send this message back to the person, right? That is with a sender.tell, because we have reference to their actor, their iActor ref. So that is what this is doing. So we're able to now create just a single instance of this actor, and this single instance of this actor gets the messages and it just logs it. So if you want to test this, I'll just run this.
So while he's trying to run his project, if you have any questions, you can put up your hands or you drop them in the chat so we read it up for you. All right, thank you.
So now you see already some of the disadvantage I mentioned in the slide earlier on, which was challenges, message ordering, right? Because I have this actors could see the order of the message in some formats. You have this guy coming last from in terms of the login. You have 94, 100, 99, 98 and stuff. So that is something that you should be aware of. If you want to process it in a serial manner, you need to architect it as such. And so this is just one single instance of the SMS actor. The main actor gets the message. So it starts from receive a message in the consumer worker service, message received, and we do a tell to the main actor. The main actor has no log. That's why you don't see any log here. If I had put in a log here, maybe receive this message, you see main actor too, right? But it's only creating a child actor here and forwarding the message to. And now we forward this message to, and this child actor now logs the message. So this is just one instance of the child running. Now we are going to do a router-based SMS actor, and you'll be like, okay, one guy just sending SMS seems like it doesn't even make sense. Why should the actor queue and be sending SMS if we have the ability to have, let's say, 20, 10, 50, whatever number of SMS actors in memory waiting to process, right? So then you can use the concept of the routers. You do here, you have all this option. So you can see with router here, right? And if you watch here, it creates a new prop with a given router. So you do this, and now you have so many options. You can either, create the router from a config, or you can just create a new type of strategy. So what strategy do you want to use? You want to use the smallest mailbox. So these are all available strategies that you can use, right? Smallest mailbox is here. If you read, it tells you about, okay, it doesn't even tell you how it's the logic, it just directs you there. But smallest mailbox basically means that anytime there's a new event, look for the actor with the smallest mailbox and drop that message to the guy, right? You go to round robin. Round robin is like I already explained. You just go around the table. Oh, you were first. The next one is the one next to you. The next one is the one next to the next one. That's how the round robin is. So we have so many different algorithms. I have mostly used, smallest mailbox has done most of the job for me. So I mostly do that. I hardly use any of the other algorithm, except in some few instances when I've just used round robin to do something. So now you come and you need to specify the number of instances of this actor that you want to do, right? Sorry, you have a question?
Yeah, please, before you proceed, we have some questions here. First of all,
okay.
We have one question here in the chat, and someone is asking, what is the advantage of using streams over queues, right? So what is the advantage of using streams over queues? So yeah, that is the first question. And the second one, we have Kingsley raising, Kingsley is here. So Kingsley, after the first question, then you go ahead and ask your question.
Okay. So I think when it comes to stream, using Akka stream, one of the key thing or advantage you get is the ability to handle back pressure, right? So if you are consuming, let's say, messages from Kafka, and there's a huge chunk of events for that topic that you are consuming. You can specify a back pressure strategy. By default, they have a default implementation in the Akka.NET that gives you that ability to handle that huge backlog without bringing in so much events into your application memory, right? Because you consume all the application into your memory, and now you are running out of memory or something. So what the Akka stream gives you, it gives you the ability to handle back pressure without you having to deal with or develop that logic yourself.
Okay. Okay. So thank you so much. We have Kingsley here. So Kingsley, you can go ahead and ask your question.
Yeah, well done, Frederick. I just want to ask if the section is being recorded. You know, just in case someone might miss it.
Yes, please, it's being recorded. So after this, the meeting, the link will be shared to you guys so that you can go and research. And then you can also check out our YouTube channel, right? We are going to upload it over there. So YouTube, Accra, yeah. So I'm sharing the link here, our YouTube channel, so you can keep your eye on there.
All right, thank you very much.
Oh, we have David Mensah. Yeah, David is also trying to ask a question. So David, you can go ahead and ask your question.
Yeah, thanks for the presentation so far, boss. So talking about the way you pass messages to or you forward messages to the routees, you made mention of your favorite being the smallest mailbox, right?
Yeah.
In what scenarios is it not going to be worth it to use the smallest mailbox?
Okay, that's a very good question. So let me see. So let's first of all break down what you get from using smallest mailbox, right? So let's assume in this case I've specified 5 messages here, right? And let's say we have 200 messages being pushed to this routers, right? Now, because you don't really control what you are doing, like it's a framework, right? So a lot of things have been abstracted from you. So the fact that you have 5 instances of the mailbox doesn't mean that you are going to get equal distribution of work to all these 5 instances of the actors, right? So one might be slower in processing the same message. Others might be faster. So at the end of the day, you broadcast 200 messages. Ideally, you just want it to be divided by 5, and each actor should have equal number of messages. But that's not what is going to happen. Some might have 10, some might have 2, some might have 1, some might have different amounts. Now, in distributing the new one that is coming, it's just going to look at, okay, out of this 5, this guy has 10, so I'm not going to give it, right? So in terms of figuring out who to do that has some time complexity in there, right? Because you need to loop through all the actors you have and figure out the number that they have in their mailbox, right? So it's like, instead of just dropping the message to go with, you are now going to figure out who has the list and then drop the message to the list. So that time factor in figuring out who has the list, imagine you have 1,000 now, then the complexity increases linearly, right? As the number of routers you spin up increases, right? So that is a reason why I will not use it. So for example, let's say if I'm doing something that is I don't really want an algorithm to go figure out anything. I'll just do some round robin, right? It comes, go here. Because round robin is not thinking, okay, you are the last one, so go here. Next. or you want to do some random algorithm selection, because like you don't want the guy to think, right? So you just get the message, randomly pick whichever actor, you drop the message to the guy, and you are gone. So the mailbox has that complexity of you figuring out who has the least number of messages in the queue to be processed. So I don't know if that answers your question.
Yeah, so with a few experience that I have, you see, with the mailbox, just as you said, there are times you have to, the framework has to figure out who has the mailbox. And if you have 1,000 routes, then that means it's going to look through all of them and see the one that has the smallest mailbox. Then it will pass the message to. But for round robin, in most cases, it's pretty much very simple and okay and efficient.
Yeah.
It passes the message one by one. So if there are 10 routes, it shares it even accordingly. So the first person gets the first message, and then another message comes, the second person, the third person, then it starts all over again. So it's good to sometimes that the scenarios that you'll be using with any of these strategies for.
Yes. I agree. So as a matter of fact, I would say look at it from the number of routers you are spinning up, right? If I'm using smallest mailbox, I never go above 20 from my experience when I'm building stuff, right? I never go above 20 using smallest mailbox. So I just look at it like, okay, worst case is just 20. So we can figure it out and spread the work among the stuff, right? But I'm not doing smallest mailbox with a huge number of instances of 500 or 1,000 or whatever.
Okay. Thank you very much.
All right. Okay. Any other questions? Okay, then let's run this. So now we have our smallest mailbox here. We spend 5. Well, we have like 200%. Let me just do 20. I don't know. A good number. Yeah. And we have to, because we already consume this guy, same message group. So let's see something. Let's see whether we will get the messages again, right? So we run this. Consumer, if not change our consumer group here. Let's see if we get something. So you can all see that nothing came, right? So that goes back to one of the key things here I mentioned.
And there's a reason we cannot name a single day trader that's been successful, primarily focused on day trading in the long.
Okay, there was something I wanted to show in terms of you consume in my presentation, I mentioned something about you not getting to consume the event in multiple number of times, right? If you consume that, then you'll be having a problem. Imagine it's a payment or it's a messaging, then you'll be causing financial loss, right? So this guy has done that. It's like, I already consumed this guy. I'm not going to reconsume it. If you want to reconsume it, you need to change the group ID, which means this is a new instance of like a consumer group. And so, because we set this as earliest, it will go back in time and consume all the messages that has been produced in the cluster. If you set this as latest, it won't do anything. It will be waiting for latest messages before it will consume, right? So that is the good thing. So the beautiful thing about this, a use case, if you want a use case, will be your backend ran into an issue, you have a consumer and something happened and you lost data or you couldn't save data and you want to go back in time and get back the old information that was in the Kafka that you had already processed and saved into the database. Now the database is corrupt. If you don't use a system like Kafka or a queuing system and you process the messages directly from the API as and when it comes, I don't know where you are going to get those events from again to get that backup, right? Yeah, just on your own. So with something like a consumer-based Kafka, you can then just clone the consumer, change the group ID, go back in time earliest, and you can be able to then get all your messages back. So if I should run this, now that I've changed the group ID, it should go consume all the messages back again. By this time around, we have like 20 actors, routers, so we expect this to be like fast, super fast, right? Because now we have 20 soldiers just waiting to act. So this will be shorter. If I should increase the router, you even be shorter. It will keep going down, right? So that is the beauty you get from using the routers in such a system. So that is what I have for you guys. I don't know if you still have any other questions in general, but yeah, I think understanding routers gives you some good advantage in being able to do a lot of powerful process message quickly. Understanding how to spin up child actors. One may ask, why will you do routers? Keep these actors in memory, or spin an actor on the fly, let it work, and you kill it once it's done. Anybody have any decision-making process that they'll follow in choosing one strategy over the other? Okay. Yes. So, like I said.
David Mensah has a hand up.
Oh, okay. Go ahead. I don't see those things because I'm in presentation mode. So,
we are on the lookout for you.
Okay. David, let's go. When will you be like, okay, let me just create this child actors and kill it, or let me just create the routers? They should just be in memory, and just if there's no messages, they'll an actor will take up space, right? I think an actor has
So like
a
300 kilobytes.
Mm-hmm.
Like 300 kilobytes.
Yes.
So there are times you just need an actor to just perform a small action, and then you don't need to keep it. So this is very important, and that's the reason why we have the ability for you to create child actors and then gracefully terminate them. Gracefully terminate them in the sense that any resource that the child actor has used, everything will be cleared up in an appropriate way, and you conserve resources. Now, so this is for scenarios whereby you just want to do something small and just pass it over to the child actor, and then when the child actor is done, you conserve resources. But for the royalties, for instance, if sometimes your system might be configured in such a way that it will be handling a lot of incoming messages, right? And as a result, spinning up one actor can do the work, but there are more advantages to using routines. And the reason to goes beyond just using the routing, but then the strategies too that you can use. In as much as Lutra has mentioned, we have the smallest mailbox. There are a bunch of other ones too that you can learn from yourself and know how to use them. So we also have the round robin, which most people that's what most people know. That's just coming from the computer science background. At least you know how the CPUs work. And yeah, so there are times when you want to conserve resources. You think about the child at this. Sorry, yeah, the children. Just give it the message, forward the message to me. The child then you just gracefully terminate it to conserve resources. Partial parents are now still there. But if you be handling a lot of requests, we just have to think of an advanced way, and we have to use the routers or the routers. So the router, so basically that's what I think.
Yeah, super helpful. Thank you so much. Anybody else? So yes, so just to add to it, so I believe sometimes you are faced with resource constraints in terms of the physical server that you are even using, right? So imagine you build something on an IoT device or a mobile phone. I think I've implemented Access in a Xamarin app before. And you are pushing, let's say, data from that device, that IoT or mobile phone to the server to do something for you, right? You have some limited resources over there. So in that case, I will look at it from a perspective of like, okay, I don't have that bandwidth to just put up actors to sit in memory. They are not working. Like they are taking salary, but they are not working, right? And so you want to be very conservative with just spinning those things up. In other scenarios, you have a very busy server. Like the server is so busy, it's like you just know that every second request is coming, every minute more requests is coming, like in that order, right? So there's not even going to be time for you to be spinning things up because spinning up an actor is also an expensive process, right? It takes time for all the initializations to happen for the actor to come up. So that extra microsecond, millisecond, nanosecond, whatever it is, eventually adds up or catches up, right? It is. So your system is busy, so you don't want to waste time. So when you are starting your system, you just get your soldiers ready because you know the war will come, right? So it's not now that you just want to come spin up actors on the fly to do something because you know already that these actors that I'm spinning up, like their events are just coming in an unending manner. Like it just keeps coming up. So you just spin up the routers and just wait for the request to process because the request will always come. So these are some of the things that you need to also consider in terms of when you're making decisions to either spin and kill actor on the fly or just let them be in memory waiting for requests to process. Okay, so if there are no more questions, I think I want to thank everybody for participating in today's episode. Hopefully we can have a different session on other way of dealing with Kafka messages using the Akka stream, which is my most preferred way. This was just a lightweight version of getting you to build your scalable and distributed architecture to handle this without any. As you can see, you've not written any semaphore, nothing, right? You just concentrate on your logic and you're gone. Everything is being handled under the hood for you. So, yes, I appreciate you and thank you. All right, over to you, host.
Yeah. So thank you so much for the wonderful presentation. We have learned a lot. So at this point, if you have a question that you want to ask, you can go ahead and ask your question. So any question at all, you can go ahead and ask your question. So this is a question time. Okay, so first we have David. David, you can go ahead and ask your question.
Okay, thank you very much. So Richard, apart from Kafka, is there an implementation for the other messaging systems like RabbitMQ?
Yes, I believe there are other packages. So we have the Akka stream as a package itself, which you can hook it into any messaging queue system. So to hook it into Kafka, that's when we have the akka.stream.kafka. But I believe there should be libraries for RabbitMQ that you can easily implement with it. And I don't know about the other ones, but I know, yeah, RabbitMQ should be pretty much easy to do. I've not used RabbitMQ in any way before.
Trying to, I don't know if you can see my screen, David.
Yeah, I can see your screen. Yeah.
There are various implementations for Akka streams. Even .NET channels.
Yeah. Yes.
Have an implementation for streams and SQS and Azure Service Bus. You can even run a stream on a CSV file.
CSV, yeah. I knew it would be there.
Exactly. Wow. So you can do Signal Arrow streams. You can do XML as your data store. There's so much you can do. It's
powerful.
It's up to your imagination. So there are a lot of things you can actually achieve with that. So it depends on your curiosity and how much time you want to dedicate to finding out stuff, because there's no real documentation on these. Let me see if I can find project website. You have to
figure it out.
If you understand streams, then you can be able to find out about those as well. So you can dig in. You can dig in here to see if you can find some stuff about it. Streams, yeah. So streams quick start guide. When you understand the basic lingo of what a stream is, then you can be able to apply it in the various what's it called, message stores, because Akka streams treats all of those guys as message stores. They are not special in a manner of speaking.
Okay, thank you very much.
Okay, so we have George. George, you can go ahead and ask your question.
Oh, okay. Hello, yeah, please. Thank you very much. So please, with regards to the routers and the actors, so let's say maybe you have a service that's just doing like basic calculation on maybe a payroll system or something that is a little bit trivial. Does it depend on the load that you are trying to process, whether you should go in for routers or should go in for the actor systems? Please, I don't know.
Okay, you mean spinning an actor on the fly?
Yes.
So, okay, so like I mentioned, so if you are doing something that is okay, let me make it practical a little bit. Very easy. An actor will definitely need something to work, right? So, for example, in a database operation, right? Look at it from that perspective. Probably that would make sense. Database, you open connections to the DB, right? And you can maximize your connection depending on the number of pools you have. So you spin up, assuming the pool is 100, and you create something like a router with a number of instances of probably over 100, right? Some of the actors will not be able to access that database, right? So now that's intuition of having a fair idea of the resource limitation that you have will help you to compute the mathematics in order to know that, okay, if just my service is taking all the 100 instances of the DB, any of that service that needs to also connect to the database will not get access, like a back office, like something, right? Some dashboard, some Grafana dashboard, like something. It's not going to get access because you are holding on to that connection, because you create the routers and they all start up, and maybe you are just waiting and you've open connection because you want to get an event and go and write something to the database, right? So in that case, you need to probably just be like, okay, either I'll use less of you or I'll create you do your job, you close the connection is returned back to the pool. Something like that, right?
Yeah, okay, I get it.
Yeah.
Okay, so I think we have Ifa. So Ifa, you can go ahead and also ask your question.
Okay. Okay, hello. So my question is for let's say my personal something. So I've been learning JavaScript, Node. I use Node and Vue. And basically I was finding out what other language should I learn. So I came about Python and C sharp. But I don't know, since you people are in C sharp and I saw this on LinkedIn, I said, okay, let me ask people in expect that what should I take in the near future? Which one will help me more? Because I want to take something to learn. So I've been using Node and JavaScript for 2 years. Yeah, I self-taught myself for 2 years. So now I want to learn something. I want to challenge myself to it another thing. So I want to find out your view about it. Yeah.
And then are you working you said you have been using Node and JavaScript for 2 years.
Node and Vue. That's JavaScript.
Yeah, Node and Vue. Okay, good. So
Yeah.
are you working for a company or are you normally work on your personal project and all that?
Okay, for my personal project, yeah.
So we have not been working for a company before.
No.
Like a professional project. You have not been working on you are just so Node and Vue is just like you are learning your own stuff.
Yeah, my own stuff.
And then you are not okay with that, or you are not content with that. You don't feel like you are in the right place. You want something you want to explore in another thing, right?
Okay, for me, I'll build things in Node and Vue. I'll build 5 applications in Node and Vue.
That is working. Yeah, you get
Yeah,
5
that's
production.
working. Yeah, I've hosted them. They are working. Yeah.
Okay, good. Yeah. So then you can explore C# and .NET. I think this community can help you to learn .NET and C#. So in this community, we talk about C#, .NET, Azure, and we have a lot of seniors engineers in there who can guide you anytime you face any challenge. They are ready to help you, right? So if you want something that is more enterprise level, then you can try the .NET and C#. So in .NET, you can also build a front-end application with Blazor, and then you can also build mobile application with Maui. So if you want that environment, like I think JavaScript, you can build a React Native mobile app, Node for backend, React, Angular, Vue for frontend. So in the .NET ecosystem, you have everything in place, right? So we can say that 4-in-1 or 2-in-1, 3-in-1, based on what you want to do. So we have Blazor in there for front end, we have Maui for mobile, we have ASP.NET Core for web APIs. So we are happy to have you here, and yeah, so we can help you. Yeah. So okay, you have another thing to say. You can go ahead. Tell me. Do you have anything, or are you okay with that?
No, I'm okay. But how can I find you guys on LinkedIn or?
Oh yeah, so that is one thing that I'm going to talk
Everywhere.
about. Yeah,
On Twitter,
yeah,
we're on LinkedIn,
yeah.
Accra.net.
So
Oh,
basically
Okay.
we have our YouTube channel here. You can subscribe to this YouTube channel where we have a lot of content we normally. So all these things we are doing here is going to be recorded, and we are going to upload it on this YouTube channel here. We have our LinkedIn page here. You can follow us. All the updates and everything is going to be here. We can also find us on Meetup. So in here, you see we are part of the .NET Foundation group. So you can also find us here. And then one thing that I want to talk about is that we have a foundation project that we have built. And this is a project we call countrydata.net. It's a .NET package that helps you to get some kind of country data. So if you are here and then you are building something that in .NET that you want something like country flag, country phone code and everything, you can get all of them in here. So you can check this package out. If you have a suggestion and everything, you can also go ahead and propose you can contribute to this package. So if I'm going to send you a form that you can register and then become official member in our group. So let me send you a message, or you can. So let me do that one quick right now. You can register and then become part of our official group member, become an official member. So you can join our WhatsApp group in case of anything. And I'm going to also share some kind of resources for you so that you can go ahead and then start learning .NET and Azure and all the .NET stack, right? So yeah, we have a WhatsApp group. I'm going to send you a link right now. Let me find the link here. Give me some minutes so you can join our group, and then you can follow our social media too. So do well and follow us on Twitter, LinkedIn, and all the social media platforms. So I'm going to paste this link here. So register, fill this form, and everyone here, if you want to join our platform as an official member, you can then go ahead and then fill this form. We have a lot of things coming up. So if you also want a series about Kafka, Akka.net, and other technology, you can also let us know. We be glad to also do a series on our YouTube channel. So if you have any question about this event, you can always reach out to our speaker, or you can reach out to us, and then we are ready to help you. So thank you guys for joining. And next month we also have another exciting events coming up. So keep on following our social media platform, and then all the updates is going to be in there for you. So thank everybody, and thank our speaker for a wonderful season today. This is a very amazing, and there's going to be a link. We are going to share the resources, the code, and then the video and everything. So if you are not part of our official WhatsApp group, you can reach out to us. So if you have something to say again.
okay. I wanted to ask that when I was developing myself coming up, I saw that mentorship is very key. So I wanted to also know if you guys have mentorship inside the group inside, because since I was growing up doing my own stuff, I saw that if I have a mentor, I will have moved faster. So I wanted to know if you guys have mentorship so that the person can guide you day in day in out. I think something like
So
that is a key. So,
sure. The entire purpose of the community is for that purpose, right? The entire purpose of the community is to help out people who are starting out and need direction. But a good direction is not what do I do. A good direction request is I'm doing this and I am stuck. How can I progress? So compare those two scenarios. I have to now come and listen to you and tell you that, oh, since you started from Node, go and do this and this. But if you say that, oh, I am trying to solve a race condition problem in Node and I can't figure it out, maybe if I don't know Node, I can use .NET to explain this to you better, right? Oh,
Okay.
I'm trying to solve a problem. Oh, this problem requires queuing. So go and read about queues and see how you can use it to solve it. So those are good problems to have. If you don't, and if you are not doing anything at all, it can be hard to show you exactly what you should do to get out of one situation or the other, right? But if you are doing something
All
and you
right.
are just drop it in the community. I'm sure somebody will be excited to help you out. There are so many experienced people in there. So if they are not there, of course, I'll also try and pretend I'm experienced and try and help you. So we can all help each other.
He's experienced. He's experienced.
Yeah, we have. I think we have another person, Nathaniel, or I'm not seeing the name. Oh, yeah. You can go ahead and ask your question. Who is this person?
Is
There was
that
another. There was another. There was another.
Someone says they need project experience. This is what I'm talking about. This is very vague. What does project experience mean? You want to work on somebody's product for free so that you can gain experience. Is that what you mean? Is it Simu? I don't know if I'm mentioning your name properly. Can you unmute and speak? We'd like to hear you. Okay. Anyway.
There is another hands up. Who is this guy?
It looks like Nathan or Nathaniel.
Nathaniel or Nathan at the cow. You can go ahead and ask your question. You just drop the hands off. Okay.
Oh, Nathaniel Adika. Anyway, also I think I have an article here that talks something small about actors, but this is more for it's creating child actors in dependency injection environments. So, Lutz, I would like you to take a look. I'm sharing it here.
Okay.
It will be a nice addition for what you have shown. But yeah, so when you get some time, you can take a look at that as well. That's pretty much it. I think in the absence of anything else, we are approaching our 2 hour mark. We are about 3 minutes shy, and so we can call it a day.
Yes. So yeah. So